So in this video, we are looking at reflecting graphs in the x-axis and the y-axis. Now, when you are reflecting, what this basically means is, for example, this part's talking about to reflect something in the y-axis. It means to treat your y-axis here kind of like a mirror, and the graph is going to get reflected along this line. And we're going to show this basically through tables of values and a couple of extra examples just to help you get your head around it. But in essence, when we want to reflect in the y-axis, we replace our x input with negative x. And we're going to see the effect of this when we look at this first example we have down the bottom. Now, if the graph is a function of the form f of x, the new function rule to reflect it in the y-axis is going to be f of negative x. That kind of makes sense because the input being negative is going to have something to do with, say, your x is a negative instead of a positive, the output will change. So you're going to see this nice reflection happening around the y-axis. Now, I've gone in and just graphed a common function, easy exponential that we've been dealing with before, y equals 2 to the power of x. And I've put in all of these outputs here. You can pause the video and put them into your calculator just to double check. But what we're going to do is here, we want to reflect this in the y-axis. So my x input becomes negative. I just stick a negative sign in front of this. And we're going to see what's going to end up happening. Now, if I were to substitute in negative 3 here, this would be 2 to the power of minus 3, which is 2 to the power of positive 3, which gives us 8 over here. If we do the same thing with negative 2, this will give us 2 to the power of minus 2, which is 2 to the power of positive 2, and vice versa. So as I make my way down, I notice that these numbers going down here is the same as these ones. It almost kind of looks like a reflection. We have this kind of opposite direction thing happening, and you're going to see this graphically as well. Now, when x is positive 1 here, you're going to get 2 to the power of negative 1, which is going to be a half, 2 to the power of negative 2, 1/4, and 2 to the power of negative 3, 1/8. So we are going to now plot these points in. Now I'm going to start from x being negative 2. So when x is negative 2, y is going to be positive 4. When x is negative 1, y is positive 2. When x is 0, y is 1. And we can kind of see this starting to play out. Now, if I were to connect these dots and graph this, so I want to pass through all of my dots, I'm going to get a nice curve happening. So I can see now, based on how this curve looks, that my graph y equals to 2 to the power of negative x is a reflection. You can almost treat this as a bit of a mirror. Everything that goes down like this on my red graph is reflected with the blue graph. As my blue graph goes out, the reflection goes out as well. Now, we're going to look at another example, which is a parabola. Now, if we wanted to reflect this parabola in the y-axis, all we are going to do is we are going to replace the x with negative x. And essentially, we can do this just by kind of eyeballing it. If we look at this particular graph, our mirror line is going to be our y-axis here. So the intercept of our graph is still going to pass through here. It's going to go down and hit my x-intercept here, and then it's going to make its way back up. So just eyeballing it and drawing it, we can see that this graph is going to pass through here. Oh, that's terrible. Let's try that again. We have our parabola going like this, and it will make its way up on this side as well. So you can see that the graph has been reflected. We are basically just looking at it visually. We are going to reflect it. So as this goes down in this direction up to positive 2, this one will go in the other direction towards negative 2, and it will turn back up, same as this one turning back up. As this goes up to here, this one once again is reflected. Now, Replacing our x by negative x gives you this equation, but you can also, just to show this and write this red graph in a simpler form, we can take out a factor of -1 from the brackets. Now, because this is squared, this will become y equals to -1 squared multiplied by, because we've factored out the negative, everything in here is going to become positive. And this is just going to give us +1 times x plus 2 squared, which gives you just x plus 2 squared back. And looking at this particular graph in terms of when you think of our horizontal translations, x plus 2 means a shift 2 units to the left, which we can see before our previous graph was shifted 2 to the right. Now we are going 2 to the left. So the reflection kind of makes sense algebraically as well. Now, next one, we are talking about reflecting in the x-axis. So this one, we looked at this being flipped around the y-axis. This time we are flipping around the x-axis. Now, to do this, we're going to replace our positive y by negative y. So anytime you see y, you are going to stick a negative in front of it to reflect in the x-axis. Once again, if it's a function f of x, the new function rule will be negative f of x. So here we have y, or f of x, equals to 2 to the power of x, the same graph we did before. We are going to look at what happens when I stick this negative in front of it. Now, you will see here, when I put in my negative, I will get negative and then 2 to the power of -3. Now, 2 to the power of -3 is an 8th. A negative in front of it will give us -1 over 8. Same thing as I go on. This one will be -1 over 4, -1 over 2, -1. We get -2, -4, and -8. This is just putting things into your calculator. So I'm going through this a bit quicker because we've looked at tables of values plenty of times on this channel before. So once you input all of this in, you will get this in your table of values. Now, once I start plotting it in, you'll notice that this time the numbers are exactly the same, just the sign is different. So the output, the y that comes out, it's that same distance here from the x-axis, but there is just an opposite sign. So we're going to be lying in this negative part of our Cartesian plane where y is negative. So if I draw these in, I'll start over here at a really easy point. When x is 0, y is -1, y is -1/2, y is -1/4. Here, when x is 1, y is -2. When x is 2, y is -4. So if I connect the dots for this one, you will see, connecting everything through, you will see my graph looking like this. And once again, as we expected, our mirror line is this x-axis. And if you sort of tilt your head to the side, you will see this reflection happening. And it is perfectly mirror reflected along the x-axis. So my rule here is going to be y equals to 2 to the power of -x. Now, applying this to that same quadratic as in the previous example, we want to reflect it this time in the x-axis. So remember, when we want to reflect in the x-axis, we replace the y with -y. Now, with our rules, remember, we usually like y on its own, so we can get rid of this factor of -1 by either timesing or dividing -1 to both sides, and I'm going to get positive y equals to -x minus 2 squared. So that means that we have the same shift towards the right, so I will still be passing through this point, but the coefficient of this, so this is our a term. Remember when we looked at our transformations of quadratics? This means a reflection. So the thing is going to get flipped. So all of the positive outputs, all the y values here, will become negative on the other side. So my new intercept here is -4. And drawing everything through, you will notice that I get that same parabola, but it's just been reflected. And we can even look at that just turning our heads, treating this as a mirror line, this x-axis, we can see that it is reflected on the other side. So this is my graph of y equals to negative x minus 2 all squared. But this is how we can reflect in the x and y axis. Once you just follow those steps, you can test it out with a table of values, you will be able to be reflecting your graphs in any direction you'd like, along the x-axis or along the y-axis. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.